All right, in this video I thought I'd go through some of the components in an engine compartment. Now in this case I'm using my truck because there's a lot of room within this engine compartment. You'll be able to see a lot of the components a little more, they're easily and readily available, whereas we're going to take a look at a 6-cylinder or a 4-cylinder and you'll see how compact everything is. To begin with, this is an 8-cylinder engine. There are 4-cylinder, there's 6-cylinder, 8-cylinder, all a matter of the smoothness and the amount of torque or horsepower that you want. In every case, engines are defined by displacement. In other words, you can have a 1.9 liter engine. You would have a 5.3 liter engine, a 5.9, that's what this is, a 5.9, a 2.3, a 2.0. Those are all sizes of engines. Now, with that in mind, what the displacement means, what this liter means, it's like a liter of soda. You know, you're talking about the measurement of the volume of that. And what you're displacing here is the volume of compression through the whole engine. In other words, you'd measure the diameter of each cylinder plus how far the piston goes up and down. That would be the volume of that, the cubic volume of that cylinder, and then you multiply it by the number of cylinders. So 1.9 is a 4-cylinder engine, and it has the diameter times the actual movement of the piston times 4. So that's what the liter, 1.9 liter is. Now, all cars, with very few exceptions these days, are they're fueled by fuel injectors, and you can see the fuel injectors. In this case, they're readily available. That's these red things right here. Each of them, each cylinder has some of these injectors, and in that case they open real fast. They're like a little piston in there, and they're opening real fast to get the air gas mixture into the cylinder for its combustion, and that's governed by the computer. Now, in addition, each cylinder also has a spark plug to spark the gases. What happens is that you have, as you might have known, the engine is got a cylinder with a piston in, and there, in this case, it's a 4-stroke engine. It has valves at the top. The valves have to be closed in order for this to be compressed and spark to be added, and that gives it its power. Now let me go through some of the components along the way. This is right here is the brake, the master brake cylinder. This is the brake cylinder reservoir. This is the vacuum assist for the braking. In other words, as you step on the brake, there's a piston in here that moves, drains some of this brake fluid out into these lines that head out to the back wheel cylinders or the front calipers. This vacuum assist just makes it easier and much more responsive in braking along the way. In addition to that, you have power assist steering. This is the power steering. This is the assist. This is a power steering pump right here, and this power steering pump pressurizes the fluid so that as you turn the steering, it's assisted by that pressurized fluid. If you didn't have that, you wouldn't be steering this car with a darn, because it's a truck and it's just too much weight to try to steer the car. Now, as you look at this part of it, obviously this is the battery. The battery is positive, negative. Virtually all cars in America are negative ground. In other words, that battery is then grounded to this engine right here. It has to have a stable ground in order for all of the electrical to work. It's a positive end of things. This is where the power is coming out to everything. It's like anything else that we talked about with regard to electrical. Now, with regard to that, this is a system that is charged by the alternator sitting at the very top. Most times the alternator is right at the top of the engine because that's something that you're going to repair. Now again, the alternator is taking that motion, that type of cylindrical motion, revolving motion, and turning it into electrical power. Within that alternator are some voltage regulators, so that when you start your car, you've drained this battery of some power, and that voltage regulator is going to direct some power back into that until that's filled up, and then that's going to shut off that circuit to end up there. Now, there are other things that you're going to have. You're going to have lights, you're going to have lights, you're going to have heat, you're going to have windshield wipers, you're going to have brake lights. Everything is electrical, so those things are still running. Now, when this dies, you can, I mean, obviously, when this malfunctions and this dies here, you can still run on this, but not for very long. You might be able to run on this. This is probably in the neighborhood of 500 amps, and you could run this car for maybe 20 minutes, and then that's flattened out. But it's running solely on that. Now, again, if you're looking at the amperage that you're using, if you have more amps than this alternator is putting out, you'll see a distinctive problem as you go along. For example, if this alternator dies, you will see that just erode away all of the power that you have in there. Or if you have a big subwoofer in your car and it's really bleeding a lot of power, more power than that alternator can take up, you'll see that as it pulses, it'll weaken the lights. You'll go down the road and you'll be able to keep time with the music as the lights go up and down in time with the music. What happens in this thing is nowadays they have one belt, and it's called a serpentine belt right here, and that runs all the components here, and I'll go over the other components that are there. But that serpentine belt, exactly as it would understand, it serpentines, it runs around in circles. You can see this thing is running down here, it's over here on the alternator, it's running all these components along the way. Once this breaks, all those components stop functioning. So that's why it's important for you to continue to maintain a good belt along the way, a good serpentine belt. Two things are necessary for a car to run. One is gas, the other is air. Those two things are absolutely necessary for this to run. The other thing is electrical. If it stops running, the automatic thing is, does it get gas? Are the spark plugs have electricity to them? Those are the two things you got to ask immediately. Now, there's a lot of things that determine whether they do or whether they don't, but those are the two things that are the initial questions that you have to answer. Now, there are two things that will keep a car running. Without them, this would run, but it wouldn't run very long, and that is oil and some kind of coolant. Of those two, the coolant is far more important than the oil, although you could run that engine without oil, and once it has burned itself up, then it's just a solid block of steel, and you junk it. On the other hand, without this coolant in here, this is going to last maybe 10 minutes, and then it's seized up, it's junk as well. So my point is, you always have to check this coolant to make certain that you have coolant in this engine. Otherwise, it's going to be just a mess along the way. Now, as you look at this, once again, there's a component right here. This is the air conditioner compressor. This actually compresses the Freon, the 134R Freon, so that it can then go through the condenser which is at the front of the engine, and then condense so that you have that coolant going along the way. In addition to those components, some cars have the water pump running right on this same serpentine belt, and this one does. As a matter of fact, the water pump is right here. Let me see if you can see this one. It's right down here. Right there is the water pump. So in order for this engine to be cooling, you have to run that coolant through the radiator, back in through the engine, and then it's a circular motion along the way. But if you don't have that pump running, it's not turning that fuelant through this radiator. The radiator has tubes in it with fins, and it's like taking your hand and putting it out the window when it's 90 degrees out, and you put your hand out the window and feel that breeze. Your hand actually cools off, and that's the concept behind this radiator. It's got a fan here. The shroud is hiding that fan, but the fan is here sucking air through that radiator constantly. And once you get up to speed, there's a great deal of air passing through that, cooling that coolant down. But it has to run through these hoses. There's an upper hose and a lower hose. It's got to come through that to make it past these fins and back, cooling that engine. In addition to that, you have a thermostat on there. When you start up a car, you're heating up that coolant in that engine, and you're cooling that coolant down. You're heating that coolant up so that you got hot air coming in there. But once it reaches a certain temperature, like 218 to 220, something like that, then that thermostat opens up, and then we're passing it into and through this radiator along the way. But like I say, if this serpentine belt goes, no coolant, no alternator, no power steering, you'll find out that that's not working real quick. So those are the things that are absolutely necessities for this car to continue to run. Now, as you look at this engine is got these spark plugs. Each spark plug is connected. If you see it back here, there's a distributor back there. Each one of these spark plugs has a spark plug wire going to that distributor. And what happens is there's a rotor that's going around in circles and distributing that spark to each one of the cylinders at the correct time. In order for that to get hot enough to explode that, you have a coil, and in some cases in four-cylinder cars, they have coil packs, and the coil pack runs all of it. You don't have to worry about that distributor at all. It's really governed by a computer that's sending the right amount of voltage to each one of the cylinders. Now, the coolant here, this is an expansion tank. And all that does is, once this gets so hot that you'd have the more coolant than this could hold because it's expanding, gets into this expansion tank. It comes through this tube into this expansion tank. And then once the thing all cools down, it drains back into the radiator. So you're looking at this right here. When it's hot, you don't even open this up. It'll just explode. It'll be stuff you could really burn yourself badly. But even though it's hot, you can open this up and you can look at how much coolant that you have in that system. It's best not to put cold coolant in there, because it has a tendency then to back into a hot engine. There's a possibility that you'd crack the engine block along the way. So some of those things are absolutely necessary here. The battery, I'm going to have to talk about this, and it's important to know. In our climate, people are constantly having problems with their car in the winter, and they need a jump start. And that's a neat deal. You can help another person out by jumping their car, but know what you're doing. You have to connect the red to the red, the positive to the positive, and you have to connect the negative, the ground, to the ground. Now, a lot of times they'll say don't connect it right to the top of the battery. If you have issues, it could blow up, then blow the top of this battery right off, and that's not what you want to do. So they'll have you connect it to something on the engine block so that it wouldn't be going right through this top of this battery along the way, that it would be cycling away from you. But always connecting the red to the red, or the positive to the positive, and a negative to a negative. In other words, you could put the negative jumper cable on that battery that's dead, but on yours that is running, you would connect it, you would ground it on the engine along the way. But you have to maintain that. If you get this wrong, you have a potential of blowing somebody's alternator up, or busting some fuses along the way. And fuse links are hard to do. You drag it to somebody and they're going to have to take a half a day to put new fuse links in it. This right here is the relay and fuse box for this engine compartment. So much of what you're talking about, checking fuses, checking relays, is right in there. A relay is simply just something that boosts the power from one part to another, and it'll be like a switch along the way. For example, if you have a fuel pump, an electric fuel pump, it is switching that fuel on and off as you work with it. Now, obviously, this is windshield washer fluid. It's easy to determine. The dipstick, always check when the engine is off. You check the amount of oil that you have, and it's good to shut it off and let it sit there while you're pumping your gas, and then you could check it. In this case, can you see this right here? This is for the transmission. And in that case, you have to park on a flat surface and leave the engine running in order to check that transmission. But that's a very, very significant thing to look at. But you can't put more transmission and fluid in it. If you put too much, it's going to ruin the transmission. It's going to ruin some of the valves that you have there. So you don't want to do that. I think we're going to stop there, and we're going to look at a 6-cylinder.